Welcome back to Soul's Game Dev Journey, your companion in the world of game development. Hello everyone, and welcome to the third video of our series Create a Turn-Based Strategy with Unity. Today, we're going to explore the Unity editor and discuss some common beginner mistakes. We will also create our first script so you can jump to 5 minutes ahead if you're already familiar with the editor window and want to jump straight to planning and coding. The Unity editor is where all the magic happens. It's where you'll spend most of your time creating scenes, building game objects, and writing scripts. The editor is divided into several windows. The scene view is where you can visually build and edit your game. The game view is where you can play your game within the editor. The hierarchy window lists all the game objects in your current scene. The inspector window shows the properties of the currently selected game object. And the project window is where all your project files and assets are listed. Now, let's talk about some common beginner mistakes. One of the most common mistakes is editing values in the inspector while the game is playing. Any changes you make in the inspector while the game is playing will be lost when you stop playing. This is because Unity reverts to the state of the game before you hit play. Another common mistake is not organizing your project files. A messy project window can slow down your workflow and make it hard to find the assets you need. It's a good practice to create folders for different types of assets and keep everything organized. A third common beginner mistake is not using prefabs for game objects that you use repeatedly. Prefabs allow you to create, configure, and store a game object complete with all its components, property values, and child game objects as a reusable asset. Not using prefabs can lead to inconsistencies and more work in the long run. The most incidental and annoying mistake is editing in the play mode. Thankfully, Unity allows you to change the color of the editor when in play mode to help you avoid this mistake. This can serve as a visual reminder that you're in play mode and that any changes you make in the inspector will be lost when you stop playing. To do this, you can go to Edit, Preferences, Color. Find a property called Playmode Tint and pick a color you prefer. Now, let's create a 3D object in Unity. Go to the Game Object menu at the top, hover over 3D Object, and select Cube. The cube will appear in your scene view. If you look at the inspector window, you'll see that our cube has several components attached to it. These components define the properties and behavior of the cube. For example, the transform component determines the position, rotation, and scale of the cube in the scene. Components are essentially the building blocks of every game object in Unity. They define the properties and behavior of the game object they're attached to. You can think of a game object as an empty container, and components as the items you put in that container to define its characteristics. One of the key principles of using components in Unity is the concept of composition over inheritance. This means that instead of creating complex hierarchies of inherited classes to define the behavior of a game object, you can simply add or remove components to change the game object's behavior. This makes your game more modular and easier to manage. Unity provides a wide range of components out of the box. These are many different components for all the different needs. The most important is the transform component, which defines the position, rotation, and scale of a game object in the scene. Every game object must have a transform component. We also have physics components, UI, audio, video, control, etc. There are many other kinds of components which you can check in the Add Component button located at the bottom of the inspector window under the last component. By understanding and using components effectively, you can create a wide variety of game objects with complex behaviors. Next, let's create a basic folder structure in our project window. A good folder structure can help keep your project organized and improve your workflow. For example, you might have separate folders for scripts, scenes, prefabs, and assets. Right-click in the project window and create a scripts folder. We will further organize as we grow the project. Now, let's create a simple script. Right-click in your scripts folder, go to Create, and select C# script. Name your script and double-click it to open it in your code editor. In our case, we will start with a HexGrid, so this is what we will name the script. In this script, we can write code to control the behavior of our game objects. It inherits from mono behavior, which means you can attach it to game objects and you get access to lifecycle methods. Two of the lifecycle methods are already here. The start method gets executed soon after the object is created. The update method, on the other hand, gets executed every frame of the game. There are a few other lifecycle methods we will learn about in the future. For now, let's just print a message to the console when the game starts. In the start method, type debug.log hello world. To attach the script to our cube, simply drag it from the project window onto the cube in the scene view or hierarchy window. Now, when you play the game, you'll see your message in the console. Now that we're all up to speed with the basics, we can start coding. But before that, let me lay out the general idea for the game. The game will feature a map similar to the Civilization games. Different tiles will have different terrain, with different possible actions and buildings available to them. The players will be able to purchase these tiles, upgrade them, build production buildings, etc. Classic gameplay. To spice things up, there will be a separate scene with a town. This is where you will fight over the influence of the townsfolk with other players. Contributing to unique town buildings, donating to services, etc. will earn you reputation with the townsfolk. The first player to be elected town's mayor wins the game. There are many opportunities to spice things up, from election cycles, to different starting profiles of the player, to kinds of contributions the player can make, and even forming own personal militias. These are all undecided for now, but will be interesting to explore once we have our basic systems set up. There's plenty to do just setting up the basic, such as the grid, tiles, production buildings, and resources. So let's get started with the grid. From the name, you already know I want my game to feature a hexagonal grid. Hexagonal grid is more complicated to implement, but I find it more visually appealing. It also helps to remove any issues the diagonals cause. This is because all adjacent tiles are neighbors and same distance apart. So let's think about what our HexGrid class will be responsible for. 1. It'll have to have all the relevant properties that define a hexagonal grid. 2. It'll have to create the grid in one way or another. 3. It should hold the information about all the cells or tiles it contains. 4. It could have methods to get, change, add or remove individual tiles. 5. I'd also like it to have a visual representation in the editor without the need to play. Let's start with defining the properties we will need to describe the grid. Just like for a square grid, we will need to know the dimensions of the grid and the size of the individual cell. For the dimension, we could use a radius, if we wanted the whole grid to also be in a hexagonal shape. But I want a more standard approach in defining the width and height. You will notice I use properties instead of private fields with get method. There's two reasons for that. Firstly, it's an example of encapsulation principle. This means that the script controls its own data and decides how to handle it. Secondly, the approach with properties is in my opinion cleaner than the other. To expose these properties in the inspector, we can use the field, serialize field attribute provided by Unity. Let's move on. These are not the only properties we will need, but to make this clear, let's head to possibly the best resource for hexagonal grids on the internet, redblobgames.com. You have everything you could possibly want to create a hexagonal grid explained, complete with the pseudocode. In the very first section titled Geometry, we can already see that individual tiles can be oriented with a pointy top or a flat top. Below that, we can see a nice demonstration on how this affects the maths. Scrolling further down, we will see another consequence of orientation. We'll have to decide which rows to offset if we're using a pointy top, or which columns we will have to offset if we're using flat top. In either case, we can think about it in odd versus even, or, the way I think about it, move it behind or ahead. Don't forget about this resource if you want to fully understand the code we will be creating in the future, and especially if you get lost or want to customize the code. Now let's add the enum for hex orientation. We could use Boolean, but this is far more clear, and in a few days we'd forget what exactly it means. Later we will also create a prefab for an individual hex. So we can add the property now. Going back to the Unity editor, I'll make a new scene for development and add a new empty object. I'll simply call it grid. Now you can add the script to it by either dragging and dropping or finding it in the components search bar. We can see all the properties in the inspector. As you might have noticed on the Red Blob Games website, we will need to know certain dimensions of the hex. For this I want to create a new static class that will hold all the math-related helper functions for the hexagons. I will call it hexmetrics. For the grid generation, we will need to know the outer and inner radius, both of which are based on the hex size. In fact, the other radius is hex size. I will still include it for clarity's sake. The other methods are going to determine the points of the hexagon. A method to get all the corners. One to get a single corner. And a method to get the center point. I will not dive into the maths here, as this is all taken from the Red Blob Games. One thing to note here is that all the methods need to be static because they live in a static class. With all of this taken care of, we can visualize the grid. In the HexGrid class, we will create a method on draw gizmos. This method allows us to use a collection of methods to draw in the editor window. We will use it to draw our grid. We will simply loop through the height and width to go through every tile. Then figure out its center position. and draw lines from corner to corner. If we now go to the Unity editor, we can play around with the size of the grid, tiles, and orientation. The grid will update accordingly. If you don't see it, make sure that you've saved the script and that you have gizmos turned on. This is it for today's video. Next time we will actually create a grid, starting with the programmatic mesh generation. If you have any questions about what we covered today, feel free to leave them in the comments below. And if you found this video helpful, don't forget to like, share, and subscribe to Soul's Game Dev Journey for more game development content.